So basically today we'll be looking at cultivar performance, the objectives in light blue, impacts of temperature management, and I'm going to show you a few preliminary prediction tools that we can play around with to look at the effect of temperature and storage duration on fruit firmness. So we'll get going. And as Mark's mentioned, next week, Glenn will be talking about real-time temperature logging and some software tools. Then the following week, I'll be looking at post-harvest treatments with a focus on delayed cooling to reduce storage disorders. And then Christine will cover fruit maturity at harvest and how that impacts on quality. So I won't really be touching on those today, although you might have questions about it. So today, cultivar performance, some recent work with recent cultivars, particularly white-fleshed nectarines and peaches, the potential for storage disorders and how it varies with cultivar or variety. I'll use those interchangeably. Impacts of temperature management during export. So some examples of commercial simulations we've done for air freight, we've conducted for air freight and sea freight, and then predicting fruit softening using temperature and storage duration. And finally, I'll demonstrate a simple stone fruit shelf life prediction model. So harvest and storage performance issues. Basically, it comes down to 3 or 4 factors. And obviously the key one, I believe, is variety. Because we've tested probably 12 to 15 different varieties over the 3.5 years, and they can behave quite differently, even under the same temperature and storage conditions. Some are much more susceptible to storage disorders, as in flesh browning and mealiness during long-term storage or during sea freight export. And the reality is although we're probably covering familiar ground in terms of some of our trials, there's very little information about a lot of the new varieties that we're growing specifically for export and the domestic market. So I don't think we're treating new ground because we really don't know a lot about these cultivars in terms of how they perform, after harvest. So we've found some, and you'll see we've found some interesting results. The other issue is that basically a lot of these varieties we're sea freighting, and the reality is that sea freight is taking between 3 and 4 weeks, just the sea freight component. It's not 3 weeks, it's not 21 days, it's generally well beyond that before they arrive at the importer overseas. So these cultivars, some of these are unlikely to actually be, sea freighted successfully because of these storage disorder issues. And then you might have the importer storing the fruit for 1 week or more, waiting for the right time to market the fruit. So that is a major issue, that duration from harvest right through to arrival at the importer can be beyond 4 weeks. Then we've got harvest maturity and the inherent variability of the fruit you're harvesting. And this is an example here just of, in terms of sugars at harvest for Majestic Pearl. And this is fruit has been graded as ready for export. And you can see the variation in soluble solids. And we've been finding that up to 25% of fruit in a particular cultivar is lower than what we would term, acceptable in terms of sugars. So you can find quite a bit of variability even in soluble solids and sugars. And the other issue that we've had is limited temperature monitoring, particularly before export and after export. So during importer storage and beyond into retail. And Glenn's been doing a lot of work in that area over the last few years. So I'll very briefly mention harvest maturity because Christine will be going into it, but we've done a lot of work looking at the effects of harvest maturity. So there's a diagram of September bright, I think, and categorizing a batch of fruit by the actual physiological maturity. So this would be considered the onset or commercial maturity, harvest maturity, unripe, overly ripe. Obviously, you can't tell any difference between them visually, but physiologically, they're quite different. And this is the type of data we collect. Storage over 6 weeks at 2 degrees. And then after each storage period, we ripen the fruit. And these are the 3 maturities. So what we would term unripe fruit, commercial maturity, and then overripe fruit. And you can see the difference in behaviour as we move along the storage period. As I said, Christine will be talking much more about that, specific cultivars and optimum harvest maturities. And then Glenn will be discussing in detail export temperature monitoring. Some of the, very generally, what we found is with air freight, we do get variable temperatures over that actual air freight period of 24 to 48 hours. So variable temperatures and a spike in temperatures, 8 up to 12 degrees over that short period. And we don't really know the effect of these short and high temperature spikes, although in a little while I'll show you what the effect is likely to be, because we've conducted air freight simulations and used a few high temperatures to see if there's any impact on quality later on. And then sea freight, the sea freight leg, because of disinfestation protocols, is always good, below 3 degrees for 21 days and beyond. But the major issue we found is that sea freight leg is taking way too long, greater than 27 days, and can be up to 35 days between harvest and getting to the importer, which is, in my opinion, a little bit ridiculous. We can't expect the majority of cultivars we're growing to actually store that long and then ripen properly. I mean, that's a major issue. Okay, so let's move on to what we're going to focus on today. And in general, what we've found, and this is probably common knowledge, in terms of general storage behaviour by fruit type and variety, well, if we look at early season varieties, then mid-season and then late, you tend to get increasing storage potential due to reduced softening. So the early season varieties tend to soften more quickly, even at lower temperatures, and I'll show you some data demonstrating that. But you also get increasing susceptibilities to storage disorders as you move later into the season. In terms of type of stone fruit, well, the white flesh tend to be have less storage potential than your yellow white flesh peach. Then somewhere in the middle, I categorise the yellow flesh peach and white flesh nectarine as to having sort of average storage potential, and then your yellow flesh nectarine tends to have greater storage potential. But again, even though we know that white fleshed varieties tend to be susceptible to storage disorders, in fact, the later varieties, whether they're white or yellow, again tend to be a little bit more susceptible. And then you've got factors like tree age in the order, whether young trees or older trees, orchard climate, warm weather versus cooler climate orchards or regions, melting versus non-melting, although we don't really, as far as I know, really grow melting varieties anymore. So there are other factors, but these are what we've generally observed. Okay, so in terms of storage behaviour among varieties, here we have 4 varieties. So we've got the table here. Very early yellow nectarine, June sweet, an early white nectarine, polar light, an early white nectarine, diamond pearl, and a mid yellow nectarine or mid to late yellow nectarine, September bright. These are the harvest furnaces that when we ran these trials, so they're all around the 6 to 6.5 kilos at harvest. What I'm plotting here is the change in fruit firmness from these initial harvests during storage, so days in storage up to 25 days here. And this is storage at 2 degrees. And the final, and you can see how the fruit softens, or how much the fruit softens from the start. If we call the harvest firmness 100, then you can see the differences in how the different varieties behave. June sweet, you lose 60% of initial firmness over that storage period at 2 degrees. Whereas, for example, September bright, there's very little change in firmness. And then you've got your whites, early white nectarines are somewhere in the middle. So you can see what a large difference cultivar variety makes to storage potential, even at this sort of close to optimum 2 degree storage period. Down here, we've got storage at 8 degrees, which is obviously far above optimum, but just to demonstrate the same effect, same for cultivars. Yes, you lose 50% of your firmness after 12 days in September bright, but it's the other earlier varieties, whether they're white or yellow fleshed, you're losing 75% of your firmness at 8 degrees, which is to be expected. But again, to demonstrate there are differences purely based on variety. So it's very clear that variety is one of the key aspects of determining storage potential. And although we've done work for a number of varieties, I think there's still a lot of work to be done to really understand how these varieties perform and which ones are limited in terms of export. The other thing we've found in a lot of our work is storage disorders, mainly flesh browning and mealiness caused by chilling injury, which is usually related to storage duration. And for example, this photograph is of Majestic Pearl. And here we've got a sea freight export simulation. The actual sea freight was 28 days. We conducted it at Agri-Bio-Centre in our cool rooms, and we had different importer storage temperatures. So once the fruit arrived, we simulated importer storage at 4, 8 and 12 degrees. But as you see, at the end of sea freight and there was no sign of flesh browning, but after 4 days of importer storage, 4 to 5 days, you already started to get this kind of browning occurring. And it really didn't matter, end of retailing and then ripening, there was flesh browning consistently. And this picture down here is Flavour Pearl, which is the white nectarine that comes in before Majestic Pearl, and around the same part of the export chain, no flesh browning. So a big varietal difference with very similar, they come in at around the same time, and they're both white flesh nectarines, but the performance is completely different. And just highlighting a little interesting thing that we've noticed in quite a few trials, have a close look at these. This is after 48 hours of ripening. And this trend is very similar across. Importer storage at 12 degrees actually reduce the incidence of flesh browning compared to the lower temperatures. And I'll be discussing that more in 2 weeks when I talk about delayed cooling and post-harvest treatments. I won't go into it now, but just something interesting to notice, that the higher importer temperature actually reduced incidence of flesh browning. And we have developed a sort of a one-pager with recommendations concerning storage potentials and cultivars by type, so white nectarines, white peach, plum and yellow nectarine, the ones that we've studied. We provide a sea freight, flesh browning or storage disorder risk, what we consider to be maximum storage duration at 2 degrees and some limiting factors. And Christine will have more information. This is about a year old, this spreadsheet, and this information sheet, and we will be updating it, particularly these, because we've learned a little bit more about these different varieties and what the maximum storage life is. And it is available on the Horticulture Industry Network website at the moment. So if you're interested in understanding sort of variation between varieties in terms of storage performance, then this sheet may be useful to you. Okay, so finishing off that section of the talk. So beyond the service supply chain project, this is what I believe we have to look at. I've already started, but potentially new R&D is actually benchmarking our latest new cultivars against best performing varieties. So for example, any new white flesh nectarines would be benchmarked against Flavor Pearl, which seems to be a very good and robust variety, particularly for export. And we could conduct cool storage and ripening trials, as we already have. Also, optimum harvest maturity based on fruit physiology. And yeah, I mean, there's always more work to be done there. Post-harvest treatments. Well, I've already started to look at optimum cooling practices after harvest to reduce storage disorders. I'll talk about that. But then there's a lot of modified atmosphere liners and even carton liners that are being used at the moment, and we don't really know the effect of these liners on storage performance. And then the impact of fumigation for air freight on fruit quality. We've done a little bit of work, but again, a lot more. And with temperature monitoring, as Glenn will talk about, I mean, it's interesting, we don't have a lot of data about temperatures, fruit temperatures beyond harvest, but before the freight forwarder or after sea or air freight, into retail and export markets. Our data is limited, so it'll be interesting to find out more about that. So that's the section on cultivar performance. As I said, briefly outlining what we've been looking at during the life of this project. Now I want to look at impact of temperature management and storage duration on quality. And some of you may think, well, hasn't all this kind of work been done before? We know the impact of temperatures, post-harvest temperatures on fruit. My question to everyone is, do we really? I don't believe we do. We've got some general rules. Higher temperatures speed up the rate of firmness loss. That's about as much as we know. And I'll show you that there's some interesting impacts of temperatures, and sometimes they're unexpected. So the assumption is that we already know what the effects of temperature management and storage time is. But do we, particularly for current export varieties? And we may have a general idea, but a lot of growers and exporters ask very detailed questions. What's the impact of a temperature spike during export on quality? Well, it's hard to say, because has anybody really done the work? So these are some of the questions we might ask in terms of temperature management. What is the actual impact of poor temperature management? So, for example, 3 days at 8 degrees Celsius during export, or 12 hours at 16 degrees during export. What is the real impact, for example, on fruit firmness of those spikes in temperature? An objective measure, well, until we started looking at it, I mean, I couldn't find anybody doing that kind of work, especially for the cultivars we're growing. What is the impact of high air freight temperatures on fruit quality? We always worry about temperature management and air freight, but what is the real impact? How long can a grower import a cool store a variety before it won't ripen properly? Well, that's what we're trying to find out. And what about directly after harvest? Do we cool down to low temperatures, or do we delay cooling and do a bit of slow cooling after harvest? And then what's the impact of, if it's beneficial in the long term in terms of reducing storage disorders, what's the impact on fruit softening, as well as impact of storage disorders? So there are a lot of questions still to be answered in terms of temperature management and our cultivars. So what we've done in our work over the last 3 years is we've looked at air freight and sea freight. What we've done is commercial simulation trials, export simulation trials, because we've had 7 dedicated cool rooms at different temperatures available at our Agriculture Victoria Agri-Bio Centre in Melbourne. So we can basically try all sorts of export scenarios because we have access to those 7 cool rooms that can be set at different temperatures. So it gives us a pretty good ability to simulate all sorts of export scenarios. And we can do two types. We can do constant temperature storage, say 2 degrees for 5 or 6 weeks, and then ripen the fruit after each storage period. And as you see, that's an example for Diamond Pearl. Or we can actually simulate real commercial export scenarios. So your freight forwarder, your air freight or sea freight, then importer storage and retail, distribution and retail, and vary the temperatures within those stages in the export chain. So it's a powerful ability to have to actually simulate commercial practice. And what we've been doing is we've been generally been using, for our trials, we've been using fruit packed for export and ready to go. And we pick up the fruit from the freight forwarder. So we are using fruit that is already destined for export markets. So our simulations, I believe, are quite valid in terms of representing real world commercial practice and outcomes. So I will demonstrate firstly for sea freight some of the commercial export simulations we've conducted. On the left here, this is for Flavor Pearl, and this one Snowfall, which is a new white peach, probably I think an early February white peach, and Flavor Pearl is an early, late December, I think, or early January. And as you can see, we actually can simulate over, say, a 30 and 40 day period. Start of sea freight, simulate sea freight leg, end of sea freight. Then we can try different importer temperatures for, I think this is about 6 days of importer storage, or a week at 4 degrees and 8 degrees. Simulate the effect, and then the effect of retail at 8 degrees here, and then the effect of ripening, just say once the consumers purchase the fruit, how quickly does the fruit ripen down to eating firmness. So this is a ripening phase here. And as you can see, we can see the behaviours of each cultivar during export based on temperature, and we can vary the temperatures. And for example, Snowfall here, and let me step back. These sea freight legs of 25, up to 30 days, these are not unusual, as I've mentioned before. So we actually have been simulating long sea freight legs, because that's what we've found is happening commercially. And in this example, just something else to point out is that, so we've got importer storage at 4, 8 and 12 degrees. And as you would expect during importer storage, the fruit tends to soften more quickly at 12 degrees. But what's interesting is we've noticed quite often that at the lower importer storage, the firmness actually increases, which is not a good sign. It's indicating to us that at lower temperature, you're starting to get some mealiness and chilling injury, which is actually keeping the fruit quite firm. So we've noticed this spike in Majestic Pearl and a few other cultivars. And again, something interesting we've noticed by being able to vary scenarios. In terms of air freight, we've run 2 decent trials, and I'll show you some results from both of them. A few graphs here, but I'll take my time. They're pretty clear cut once you see what's going on. So this was air freight simulation. What we did was we simulated air freight over a 24-hour period, 3 different temperatures. So basically the period where from the freight forwarder onto the plane and then off the plane. And we simulated 8 degree air freight temperature, a 12 degree and a 16 degree. That's a poor temperature management scenario during air freight. Polar Queen, a white peach, very susceptible to storage disorders, but never mind. So the first graph here is what occurred in terms of flesh firmness with fruit that had no storage disorders. So clean fruit, good quality, all the way through to 4 weeks. And as you can see, there was an effect of high air freight temperatures, which is 16 degrees, 12 and 8 degrees. The 8-degree air freight temperature, well, the fruit basically remained at 4 degrees over this 4-week storage period, simulating importer storage, remained pretty much at that 6 to 7 kilos firmness, whereas these air freight at high temperatures did impact on softening, as we would expect. Although, realistically, the importer wouldn't keep this fruit for longer than a week, and after a week at 4 degrees, after air freight, there was a difference with the 16 degrees, but not really with a higher air freight temperature of 12 degrees. So, 8 to 12, probably similar result for that 24-hour period of air freight. So what can we say there? Well, the spike in temperature over that 24-hour period does make a difference, but it's only really at that really high, poor temperature management of 16 degrees. What was interesting, though, with fruit with storage disorders, the change in firmness over that 4-week period was much, much less. And as you can see, even at 16-degree air freight temperature, you only got down to about 4 kilos. When this occurs, you know that abnormal softening, I'd call this, you know that the fruit has a problem and that there are storage disorders associated with that fruit. And here we have the flesh browning incidence from 0 to 100%. And as you can see, after the first week of storage at the importer, you started getting very severe flesh browning. But again, what's interesting, just note, is that there was after 2 weeks at 4 degrees, the fruit that was air freighted at 16 degrees had much lower incidence of flesh browning, which gives us a clue to what we might want to do directly after harvest in terms of cooling, and I will talk about that in a few weeks. Now, with Flavour Pearl, we also did air freight simulation, 3 temperatures for 24 hours, 3 different air freight temperatures. But in this case, there was very little difference in firmness loss over 4 weeks at 4 degrees. And the fruit ripened pretty much normally and similarly, regardless of air freight temperature. And this is the actual physiological maturity measured with a DA meter, and very little difference in maturity, physiological maturity over that storage period. So Flavour Pearl is an unusual variety. It's a very robust variety. The maturity drops during cool storage, but there's little change in firmness. But it does ripen very quickly, and similarly, and there was very little impact of air freight temperature. Again, this highlights how important Cultivar variety is in terms of storage performance. So I think that's all I want to say there. So that's how we run our commercial simulations. Now we're going to look at some shelf life modeling and prediction. So what we've been able to do is store fruits, different varieties, at 7 different temperatures and see their behaviour over different storage periods. And this is an example for Majestic Pearl, low temperature storage, and then 8 degrees, 12, 16, and you can see the different behaviour and the short storage period as related to differences in temperature. So we collect all this data and we're able to model actual commercial export scenarios. And I'm going to do that now. So what we have here is an Excel spreadsheet with a model based on our experiments, our temperature and storage experiments, behind the Excel spreadsheet. I'm not going to show you the model, but I'm going to show you what you can do with this model. So here we have the harvest maturity. So you can modify this depending on the variety and what firmness at harvest maturity. The duration of each step in the export chain, so harvest to freight forwarder, sea or air freight, duration, importer storage, distribution and retailing, and the consumer phase. You can vary the temperature of each of those stages, and then you can get average firmness or the change in firmness as you move along the export chain. And this is the accumulate. I'm not going to talk much about it, but this is the total degree hours accumulated above zero as you move along the chain. So I'm going to double click on it and hopefully it works. Oh no, it won't because I've got to go back. So I'm going to escape, double click, and here we go, zoom in. And so we can have a look and play around with it. So I'm going to run a sea freight scenario that's probably pretty common. And we're going to assume a harvest firmness of 7 kilos. So I'll put that in. So let's assume a standard air freight scenario in terms of durations we know. So harvest to freight forwarder, I mean, we don't believe that you can get a grower can get to the fruit to the freight forwarder before, you know, any earlier than 4 days. So let's just say ideally they manage to do it in 4 days. Then, I mean, I believe that the average sea freight period is about 25 days at this stage, but let's say 22 just for the sake of this example. Okay, so we've assumed 3 degrees average temperature between harvest and freight forwarder, 2 degrees. It's more likely to be 1 degree, but let's say 2 degrees during sea freight for 22 days. And so at the end of sea freight, the firmness has dropped from 7 to 5.7 kilos, and this is average firmness. Then let's say the importer wants to store the fruit for 5 days and stores the fruit at 3 degrees for 5 days. The fruit has dropped from 5.7 to 3.4 kilos. Okay, so this is just demonstrating, and this is for Majestic Pearl, this particular scenario. And then we might say the distribution retailing takes 2 days and 8 degrees Celsius. So the consumer, after that time, the fruit firmness is basically down to almost eating firmness of 1 to 1.5 kilos. And then the consumer, you know, leaves it on their bench at 18 degrees for, let's say, 1 day before consumption, while it's eating firmness and beyond. So this little Excel calculator demonstrates the power of modeling shelf life and storage life. And so you can vary, we can run through another scenario very quickly. We'll leave that at 4 degrees. Let's say air freight is more realistic. We can run an air freight scenario, we've just done a sea freight. So let's say air freight, 2 days at 12 degrees, okay? You might be surprised that there's very little change in firmness over that 6 days at those temperatures, or don't be, because that's what you tend to find. You don't see the effect of higher temperatures until later on in the export chain. You won't see it straight away. It's just the behavior of our cultivars. That's how they behave. But then the importer storage, let's say 6 days and say 4 degrees. So after air freight, the importer stores the fruit for 6 days at 4 degrees, and the fruit's dropped down to 5 kilos. Then let's say distribution might take 3 days and might be 10 degrees on average rather than 8. You see the impact there of that temperature is only seen at the end of the export chain, where the fruit tends to soften rapidly. Even at 8 degrees, it's 1.9, and then the consumer obviously has maybe a day or a bit to consume the fruit. So I just want to demonstrate that to you, this kind of approach where a grower, exporter, importer, or retailer can use this sort of calculator to determine how quickly fruit will soften. But then there's another way of looking at it, And this is what is more likely to be used by someone along the export chain, whether it's an exporter, importer, or retailer, and to determine the remaining shelf life or storage period. So that previous calculator was just to play around with temperature and storage duration to understand how firmness changes with those parameters. This is actually useful in terms of predicting what is going to happen to your fruit based on what's already happened to it. So I'm going to run again each one and use some examples, and hopefully this is interesting for you, just to have a look how this can work. Noting that the Queensland Department is actually developing a mobile app for mangoes and stone fruit for industry, which incorporates some of these calculations into a very simple user face. This is just showing you in a bit more detail, but will not be the final product. So, okay, and zoom in a bit, we'll do, so say you're an importer, and what you've got here is, again, you've got harvest to freight forwarder, number of days, the temperature at each stage, and this tells you the remaining storage period. Now, as the importer, what you would need to know is how many days you need. If you want to estimate remaining days of shelf life as an importer, well, you actually need to know this information, and you might obtain it from your exporter, or just from temperature monitoring. And then once the fruit arrives, you could actually estimate shelf life and storage life. And you do that by inputting a desired firmness, at which point you need to sell the fruit as an importer. So you might say, I can keep the fruit until it's 4 kilos, and then I have to move it on to the retailer. So the power of this is you can select the minimum desired firmness as an importer, for example. So let's say 5 kilos. Right, so let's assume that 5 days at 3 degrees, right? So this is the importer doing the calculation. Then you know that the fruit took 23 days to get to you at 2 degrees, right? You've got a problem. Your minimum firmness is 5 kilos has already been reached, right? So this is the issue. So let's change it to 21 days, right? You will receive that fruit at 1 kilo. So you've got, sorry, that's not kilos, that's days remaining. So under these conditions, for this is Majestic Pearl, at a harvest maturity of about 6 kilos, I think this model's based on, and you can vary that, but this is 6 kilo harvest maturity. If you want to know how quickly you need to offload the fruit before it gets to 5 kilos, we've got 1 day remaining before you have to sell the fruit. But if you can hold the fruit until it's 4 kilos firmness, you've got 5 days at 3 degrees. And you can see that. If you've stored it for 2 degrees, you've got 2 to 3 days remaining. So you can play around with storage time and storage temperature and a minimum firmness to actually determine how much time you've got left before you have to get rid of the or on-sell the fruit. And again, if you can hold the fruit until 3 kilos, well, then you'll find that you've actually got, and get rid of that. When you receive the fruit, you've got 9 days to play with before you have to sell the fruit. So it's quite a powerful calculator because you can play around with these different scenarios. You know, if I increase that to 27 days, and you can keep the fruit until it reaches 3 kilo firmness, you've got 5 days rather than 9. Again, demonstrating the power of it. And you can do the same as a retailer. You do the same thing, except now that you're a retailer, so you can hold the fruit until it drops down to 2.5 kilos before it has to be sold. And if we do the same thing, 5 days, 21 days, and this is just telling you that the fruit's still fine, you can continue. The importer stored it for 3 days. You've got, as a retailer, 3 days to sell the fruit before it gets to, it reaches this firmness. And that's a firmness that the consumer would want to purchase at and consume after a few days of ripening. So I just want to show you what's possible, and ideally we will have a mobile app, a much simpler app where you can just put in some temperatures and storage periods, and it gives you a warning about how many days are left of shelf life based on those temperatures and storage durations. Okay, so I'm going to move on. And we're probably nearly there, nearly done. Yeah. Okay, so to summarize, temperature, duration and quality. Good temperature management during export is still critical. I've shown you some unusual results from higher temperatures compared to lower temperatures, but in the end of the day, good temperature management is critical. But temperature impacts on quality can depend on the variety and the storage duration. So you have to take those into account. And then we've also seen that, for example, short bursts of the warmer temperature during export, during post-harvest, the whole post-harvest chain, could potentially be beneficial. And that's why we've looked at delayed cooling after harvest, which I'll talk about in a few weeks. And you'll see that there are some benefits of potentially not fast cooling or immediately cooling fruit. Simulation trials that we've conducted have provided insights into storage potential of the different varieties we've looked at under realistic commercial / export conditions. But more monitoring, temperature monitoring is required during grower handling, cooling and packing, as well as after air and sea freight during importer storage and retail, because we really don't know what's going on at those stages in the export chain with temperatures. And we've seen that the real impact on quality due to temperature and storage time can be understood using shelf life prediction. So the next step for us is to develop these models further for different varieties, and we're looking at doing at least 6 varieties by the end of the project, or producing models for 6 varieties. We were hoping to do commercial validation this season, but with the coronavirus and lockdown, we will probably have to do simulated validation in our own cool rooms rather, because we're unlikely to get overseas. And industry probably requires a simple to use real-time mobile app, which is being developed. And just finally, I think this kind of work, especially with the sea freight, is very relevant at the moment, because it looks like it will be quite difficult to air freight a lot of our cultivars this season because of limited flights into our export markets. So we are going to have to sea freight a lot of these cultivars, and so knowing their storage potentials and whether they can actually make the journey and still ripen properly and be good, have good eating quality for consumer is really important and timely. Okay, I think that's it. Thank you very much. Mark?
Yeah, look, if there's any questions, just type it into your chat box or Q&A box below. Look, something I've heard, just to kick this off if there are any, there's this thing called kill zone that I've come across just recently about fruit. Can you tell us a little bit about that? And is that really, looking at what you've done, a fair way of gauging a problem with fruit moving in and out of a kill zone?
Yeah, so kill zone, and I mean most growers and exporters have heard of it, is this region, temperature region of about 3 to 7 or 8 degrees, where many cultivars, older cultivars generally, appear to be more highly susceptible to chilling injuries. So if they spend a period of time at that temperature, and even if they then drop back down to below 3 degrees, they tend to be more susceptible to storage disorders. Now, we have seen a little bit of that with the new cultivars, and we're not particularly sure that it's always relevant, but the recommendation is to play it safe and ensure that you do keep your fruit out of that kill zone. Now, what's interesting about that is that the problem with how we handle our fruit from harvest fruit to the freight forwarder is the fruit generally can go through that kill zone 1 or 2 times before it gets to the freight forwarder. You know, if you think about immediate cooling, then you pack, the fruit warms up again, and then you cool down again. And we're thinking that we generally want to avoid any movement through that kill zone, even with our newer cultivars. So that then we have to consider, well, how do we handle fruit to avoid too many movements through that kill zone? And that's where potentially delayed cooling comes in. So I would consider it, based on old work and even some of our work, that it's still an important issue, and it's still highly relevant for the cultivars and post-harvest practices, current post-harvest practices. Yeah.
So I'll just repeat that. So while the work has been done on export fruit, could the app be adapted to the domestic market, looking at the supply chain, grower to market agent, DC, retailer, and predict the retail shelf life for domestic markets?
Okay. So there's no reason why those models and the app can't be used for domestic market. I mean, basically all you're doing is replacing that stage that is air or sea freight export will be replaced by a domestic stage, you know, transport or something like that. So yes, that app is very applicable to both export and domestic market. I mean, the project's been focused on export cultivars, but obviously most of these export cultivars are still, well, not all of them, but the majority are still sold in the domestic market, and there's absolutely no reason. If you've got temperature, if you're monitoring temperatures and you know the length of each stage during across the domestic market, yes, you can use those tools to predict remaining shelf life very easily. Yes.
Okay. Another question. John, great presentation. Does the shelf life prediction vary for fruit held at constant versus fluctuating temperatures, even if these temperatures may average the same over time?
That's a good question. I've heard asked that. And I haven't shown the data. We've actually studied the effect of temperature fluctuation in 1 or 2 trials. I think it's 2 trials we've done, where we've looked at different fluctuation scenarios over, say, a 3-week storage period. You know, fluctuations from 8 degrees to 0, or 0 to 8, or 4 to 2. But every scenario adds up to the same degree hours. So they've undergone the same type of temperature, overall average temperature, but just in different fluctuations. And we didn't see any difference in the end result. So it appears that the order of the fluctuation, you know, whether you have a higher temperature first and a low temperature or vice versa, doesn't impact on firmness, for example. But the thing it does impact on is storage disorders. And again, as I highlighted in the talk, these shortish spikes of higher temperature appear to actually be beneficial or reduce storage disorders. Now, I don't want to come across as sounding like we don't need good temperature management. I always worry when I say this, that a spike in temperature might actually be good in reducing storage disorders. It's a controlled spike. It's not just random spikes along the export chain or domestic market because of poor temperature management. That's what you don't want. But in terms of controlled temperature, higher temperatures over a short period, as I will demonstrate in a few weeks, it's probably can be beneficial for some cultivars. So going back to the original question, we didn't see any real impact of the order of temperature fluctuations on firmness change during a storage period. No.
Do warm temperatures encountered early in the chain have less impact on remaining shelf life than if encountered later in softer fruit?
Good question, Andrew. So let me get that. So warmer temperatures, with stone fruit, even warmer temperatures early on, you don't see the impact until, and I mean this, now I can start, since I've given the presentation, we're looking at what we call degree hours, post-harvest degree hours, so basically above zero. And we're finding that regardless of whatever temperature you've got early on, you need to accumulate 1200 degree hours or beyond before you see most cultivars begin to soften, right? Assuming commercial maturity. So, and we found it across the board that this 1200 to 1500 degree hours before softening appears is pretty consistent. Now, all that means is that if you store your fruit at 8 degrees after harvest, obviously you're going to accumulate those 1200 degree hours very quickly, and then you will see softening. So it might only take you 4 days at 8 degrees and then the fruit will soften. Obviously at 2 degrees to accumulate 1200 hours takes 3 to 4 weeks. So that's where storage duration comes in, and temperature, that's how it impacts. So I would say with stone fruit, you generally see the impact of those higher temperatures during the ripening phase, not during the low temperature storage phase. That's why, just say for example, you use delayed cooling, so you store your fruit at 12 degrees for 2 days after harvest, and then cool it down to 1 degree for export. There will be very little impact on firmness loss until the other end, when the fruit moves to a higher temperature, say during distribution at 4 or 6 or 8 degrees. Then you will see the softening start to take off. And so you're seeing the impact of that earlier warmer temperature only after import and at higher temperatures during distribution. So hopefully that answers the question, Andrew. So it's a really important point, because, and the model tells us that if you get, as we just saw, a temperature spike during air freight, you won't see an impact on firmness after that air freight leg, once the importer receives it. If the fruit was 7 kilos before air freight, even at a 12 degree air freight temperature, it will still be 6.5 to 7 kilos. But you might see an impact of that higher temperature later on when the fruit is softening. And whether that's an issue, well, it depends on how quickly it's retailed. The consumer might see it in the form of the fruit ripening more quickly in the fruit bowl, you know. So again, my observations, I believe that we get a little bit carried away by these spikes of higher temperature, because they don't necessarily, for most cultivars, they don't necessarily make a change firmness to the extent you'll be able to detect it at say after sea freight or at the importer. So the detection, the softening, the effect on fruit softening occurs later on. Anyway, that's my observation. You know, don't hold me to that, but the data shows that pretty clearly.
Great.
Okay.
One more question. So Antar says, hi, John. What about the impact variation of levels of oxygen, O2 and CO2 and humidity inside the liner? Is there any work in that area?
Well, we've avoided looking at that work, because that's a whole another opening up a can of worms. But really, we want, the next stage in this work is to actually combine some of what we've been doing with testing various liners and measuring CO2 and O2 levels. I've done some very preliminary work, and I don't even remember the liner. It's a commercially available liner, and we've stored some mid-season nectarines, yellow nectarines, for 45 days in liners at low temperature, and then ripened them. And it wasn't a true experimental trial. It was just a basic suck it and see, and it seemed to work. We didn't measure atmospheres in the liners. We just had a shot at it with a small sample, and yes, the fruit remained firm. They seemed to ripen okay. I mean, didn't really taste the fruit. If there was any off flavors that can occur long-term storage. So I really can't recommend anything at the moment because we haven't done proper experiments with the cultivars we're growing now and the newer cultivars, and measured oxygen and carbon and CO2 properly, and then ripen the fruit to see what impact it has on eating quality and flavour at the end. And that's what you need to do, test the various liners available. So I hope that we can continue that work in some form, because it's critical, especially even in terms of the impact of fumigation when you've got fruit in liners, and whether fumigation is working properly or not. That's another issue as well.